Welcome to Section 5.2, Example 1 Screencast, Proving Trigonometric Identities. Proofs are awesome. Hopefully the goal for each one of these problems in this entire section is for you to get to the end of the problem and know that you have shown every step correctly and have gotten to the right answer. The cool thing about this section is the answer is already given to you. You just have to get there. Here's some strategies I put on the first page to help you along with this process. General strategy 1 I like a lot. Only work with one side of the identity. Only one side. You will never touch the other side. Now, it's not always the left, it's not always the right. You want to begin with the more complicated expression, and complicated to you may mean something different than your neighbor. There are also many ways to do each one of these, so just because I'm showing you one way doesn't mean there isn't another way to do it. It might be longer, it may be shorter than mine. It may go in circles, it may never work. I don't know, but there are always right steps to take, and hopefully they will get you to the correct goal. We've already talked about the strategy in section 5.1 about changing everything to sine and cosines. We've already worked with combining fractions. Those are tricks you'll also see in this section. We've also talked about the difference of squares. We will be using that a lot, especially with our Pythagorean identities. The other thing to keep in mind is your target expression. Always keep your goal in mind. The shape of it, the content in it. Is it just a number? Is it a trig expression that only has sines and cosines? Does it not have sines and cosines? Does it have a squared? Keep your end expression in mind. In example 1, the numerator has a difference of squares in both of these, and the denominator is made up of a part of that difference of squares. So I'm going to break up the difference of squares in each of the numerators. X squared minus 1 breaks up or factors into x plus 1 times x minus 1 in each numerator. Supposedly this is going to equal 2. And you don't have to write equals 2 every time, so I'm just going to write equals equals equals. The x minus 1's cancel out in the first term, the x plus 1's cancel out in the second term. So now I have x plus 1 minus, now I got to keep that in parentheses because that negative sign is going to distribute to both parts. X plus 1 minus x plus 1. So now x minus x is 0, and I just get 2 equals 2. Now, a couple things I want to point out in this proof. See how I was writing the equal sign on the right every single time? You obviously knew I was working with the left side because this was supposed to be equal to the same thing every time, and then finally at the end I put 2 equals 2. They are exact. I have proven to you that just by manipulating this left side correctly with algebra, I will get it equal to what the problem said it was supposed to equal. The problem will never tell you an incorrect answer. If the problem says it is equal, it is equal. You just have to prove it. Let's try another one. Example 1. Exercise 1. In exercise 1, in the numerator, I see x cubed minus x squared all over x minus, oh man, this is just so messy. Now, keeping the end in mind, that right side has no denominator. So first, let's see what I can do with this denominator. In the numerator, I see an x cubed minus x squared, so they both have x's in them, and I can factor those out. Now, one of those x's will cancel out, so I get x times x minus 1 minus x minus 1 times x plus 1. So I've gotten rid of the denominator. Again, keeping the end in mind, the right side that I'm working towards, doesn't have any denominator. It also doesn't have any squareds, and at this point I'm going to get a lot of squareds after I multiply this stuff out. So all I'm going to do is multiply it all out, cross my fingers that it will cancel out. So here, x squared minus x minus, now this mess is going to be x squared, oh, minus 1, that's a difference of squares. So I really have x squared minus x, I have to distribute the minus sign. And now I have x squared minus x squared will be 0, so negative x plus 1. I cannot leave the left side as negative x plus 1. I have to make it look exactly like the right-hand side. We are without a doubt proving that the left-hand side equals the right-hand side. So I have to write this as 1 minus x equals, and now I do have exactly what the problem said I had, 1 minus x. Now in both of these problems, the more complicated side was obvious, and it was the left side both times. It won't always be like that. This left side was obviously more complicated than just 2, and the right side was obviously more complicated than just 1 minus x. It was easier to work with the left side and simplify. You guys have a lot of experience with simplifying. Half the directions you deal with in math say simplify. So work with the more complicated one and keep the end in mind.